Have you ever wondered how language models generate such diverse and engaging responses? Today we'll unravel the mystery behind this fascinating process. Welcome to our sixth lesson, where we will explore advanced techniques for prompt engineering. Scene script. First on our list is a technique known as temperature setting. A simple yet powerful tool, temperature setting lets you control the randomness of the model's output. The temperature value ranges from 0.1 to 1. A high temperature results in creative, unpredictable outputs. For instance, if you were to generate recipe names with a temperature set to 0.9, you'll get unique names like Starry Night Steak or Tropical Paradise Salad. A low temperature, on the other hand, produces more conventional responses. With a temperature of 0.3, you might get names like beefsteak or Caesar salad. Moving on, we dive into top K sampling. This technique is all about quality control. It limits the number of options the model can choose from in its outputs, which reduces irrelevant or nonsensical options. The values for top K range between 1 and infinity. Higher values yield more diverse outputs, while lower values prioritize high probability responses. For example, if you were generating headlines related to the blockchain industry and used top K sampling with a value of 5, the model would select the 5 most diverse and relevant headlines from the 10 most probable options. But why not just ask for diverse headlines? Well, the beauty of top K sampling lies in the level of control it provides. Without specifying top K sampling, you may get a broader range of outputs, including some less related ones. By setting top K to a specific value, like 5, you ensure a more focused and relevant set of responses. This technique helps strike the right balance between diversity and quality. Lastly, we have beam search. This technique considers multiple possible continuations for a given prompt and selects the best ones. You can influence the diversity of outputs by specifying the beam width, which is the number of continuations considered at each step. A wider beam width increases diversity, but may compromise the quality of responses. Narrower beam widths prioritize quality but limit diversity. In summary, advanced techniques like temperature setting, top K sampling, and beam search can greatly enhance your control over language models. These techniques allow for more refined, nuanced, and personalized responses, making your models more accurate, relevant, and engaging. So don't be afraid to experiment and find the right balance that suits your needs. In this next segment, let's delve a little deeper into the world of prompt engineering and explore some advanced techniques that can further enhance your language models. Firstly, we have the nucleus threshold. This is a method for controlling the creativity of your model. By setting a threshold value between 0 and 1, you can determine the likelihood of the model generating unconventional or surprising responses. Higher thresholds encourage creativity, but may lead to less coherent or nonsensical outputs, while lower thresholds yield more conventional and predictable responses but limit diversity. Next up, we have input and output truncation. Input truncation restricts the length of the text used as input to the language model. This helps focus the model's attention on the most critical parts of the prompt, reducing complexity. On the other hand, output truncation limits the length of the model's response. Both input and output truncation values can be adjusted to strike a balance between response quality and efficiency. However, it's important to keep in mind that these settings might not always be applicable or effective in certain scenarios, as we discussed in Lesson 2. We also have other advanced techniques, like fine-tuning language models, combining multiple models, and employing human-in-the-loop systems. Fine-tuning helps adapt a model to a specific task or domain, improving accuracy and reducing bias. Combining models, including language and computer vision models, can enhance text quality. Meanwhile, human-in-the-loop systems involve human input to review and refine generated text. Lastly, we have prompt generation algorithms that can create prompts tailored to specific tasks or domains. In conclusion, prompt engineering is a complex field with many advanced techniques and tips to help you achieve better results. Whether it's adjusting settings like temperature, top K sampling, nucleus threshold, or beam search, or employing more advanced techniques, staying up to date with the latest developments and best practices is essential. These techniques will empower you to enhance the quality of your prompts and leverage the full potential of language models. Thank you for watching. And stay tuned for the next lesson where we'll explore some best practices for working with language models.